This is Unit 8, Financial Applications, and our first topic in Unit 8 is simple interest and rates of change. Let's go over some terminology. Principal, which we use the capital letter P to represent principal, it's a sum of money that is invested, deposited, or borrowed. So principal is usually just your starting amount of money. Simple interest, which is what our topic today is, simple interest. Simple interest is interest that's earned on the original principal only. So whatever your original amount of money is that you put in, you will just get interest on that original amount. And the difference, the other topic is called compounding interest, which we'll learn about on the next lesson. But today we're just doing simple interest. Total amount, we use a capital A for that, and that's the value of the principal that you invested, and then you add on the interest you earned. That makes sense. That's the total amount of money you have. Annum is a word that we don't really see the word very much in our questions, but we often see a slash with an A, and it means per year, per annum. So every time you see this, it means how, usually it's an interest rate, how much interest you're making per year or per annum. And quarterly means every 3 months. So here's the bond, Canada Savings Bond. It's for $300, but this question we're going to talk about here is Sonia bought a $1,000 regular interest Canada Savings Bond. And regular interest means simple interest, which is our topic today, simple interest. It has a 10-year term. That means she has to leave her $1,000 in there for 10 years, and it's going to earn 5%. And unless it's otherwise stated, an interest rate is assumed to be per year or per annum. So this doesn't say 5% daily or quarterly, or it doesn't say anything. That means we're going to assume it's per annum or per year. So she gets 5% per year. How much money did she earn after 10 years? So let's just talk about 1 year first. After 1 year, she'll have earned 5% on her $1,000. So how much money is that? That's 0.05 times 1,000, 50. After 1 year, Sonia will have earned $50 in interest, and she'll have a total amount, that's this number here, she'll have a total amount of $1,050. So her principal, the amount that she put in, was $1,000. The interest that she earned was $50, and then the total amount was $1,050. But this question says how much did she earn after 10 years? So let's look at this chart. This chart, the first row, we just did that in the previous screen here. There's your $50, there's her $1,050. So principal for the year. This column is important. When we talk about compounding interest, this number will change every time, but for simple interest, you're always getting interest on whatever you put in originally. So she put in $1,000. So for her second year, for her second year, she takes her $1,000. She makes another $50 on it. So her accumulated interest, that means added together, she's now got $100 of interest that she's made. And at the end of her second year, she has $1,100 because she has her $1,050 from before and another $50. So she's at $1,100. So her third year, same thing. She had $1,000 originally. For her third year, she got another $50. So far she's got $150 in interest. And there's her, at the end of the year, she's at $1,150. Fourth year, same thing. So I'm going to skip writing it all out and just put a 50 there. So now she's at $200, and the amount at the end of the year is $1,200. So if you have a chart here, you can fill in the rest of the chart. This is going to be 1,000 all the way down here. This is going to be 50s all the way down here. And these ones, you can see the pattern, what these accumulated interest is going to be, and then the amount at the end of the year. So let me just skip through here. Here's the 5th year. There's the 5th year, and the 6th year, I put it all in as one. And continuing on, we're just doing the same thing with the pattern. So here we are at the 10th year, at the end of her 10th year. Again, we go back to the principal, which was $1,000. She's going to get another $50. That's going to make her accumulated interest. She's got $500 now that she's made an interest, which is $1,500. So bonds are kind of unique. I'm not going to get into what bonds are like, but usually you can't take your money out of a bond until the term is up, until the 10 years are up. So she couldn't have at 6 years said, well, I want to take out this money. She would have had a penalty probably for that. But we're going to ignore all that stuff for now. We're just going to proceed as if she's just making this money regularly. So this was very tedious. There must be another way. And I'm sure some of you are already, as you're writing this out, thinking, why are we doing this? There's a better way to write this out. And I hope you've thought about that. But we're going to start by graphing this data. We're going to put year along the horizontal axis. So that'll be your x-axis will be year. Your y-axis is going to be this number here, the amount at the end of the year. So think about how you want to set up your scale on your grid. Your years, you're counting from 1 to 10. So you can spread it out depending on how much space you have on your graph. You can spread it out a bit if you want to. These numbers are starting at 1,050. So I can put a break in my graph. I don't actually need to start at 0. I probably want to start at 1,000 since that's the amount we started off with at the beginning. So here is a graph. You can see it's very faint, but the years are on the bottom, up to 10 there. And then here's your 1,000 and going all the way up here, a little higher than we need, but that's the amount at the end of the year. Sonia's graph shows linear growth, right? That's simple interest is what we did today. And simple interest is the type of function that best models the growth of Sonia's money is linear. Linear is, you can look at the dots you have, they should have shown up in a linear pattern. Part of the title for today's lesson, if you go back and look at it, is rates of change, right? The title for today was simple interest and rates of change. So what is the rate of change here for the money that Sonia has? What is the slope? That's what rate of change is. 50. And remember, M stands for slope, so her slope is 50. We want to determine the equation of the linear function that models the amount of Sonia's investment over time. So we're going all the way back to grade 9 here to talk about this question. Linear means we're writing y equals mx plus b. That's how we write a linear equation, a linear function. So it is a function, so I'm going to change it from y to f at x. And m is my slope, that's a 50. X plus b. What's b? Remember that's your y-intercept. My y-intercept way down here is 1,000. So there's an equation, a linear equation, to model the amount of Sonia's investment over time. So I would no longer need to use that huge chart from before. I now have an equation that I can sub into. And if she left her money in there for 30 years, I would just sub in a 30 right here and not have to go through that tedious chart. Now, relating this back to our last unit, what type of sequence, so that's either going to be arithmetic or geometric, what type of sequence could you use to represent the amount of Sonia's investment for successive years? Successive meaning one right after the other. Is this arithmetic or geometric? Well, if you remember from last unit, linear growth is arithmetic. And in this case, if we were talking about arithmetic, the D value, that's your common difference. In this case, the common difference would be 50. Here we've got some helpful formulae and facts. Remember that the plural of formula can be written like this, or it can be written with an S at the end. First one, y equals mx plus b, is used to determine the equations of linear functions. Next one, simple interest is represented by, a linear function. The total amount at the end of each interest period forms an arithmetic sequence. We just talked about that. The formula for simple interest is capital I for this one. Capital I equals P times R times T, where your interest is equal to principal times rate times time. So this capital I is different from the first screen. We had terminology, we used a lowercase I. That lowercase I is a little different. We'll talk about that. So the capital I is the formula for simple interest that we're going to use. And rate must be a decimal. So if you're given a percentage, like we had 5%, you would not write 5% there, you'd write 0.05. And time is always measured in years for simple interest. Let's practice this formula with the bond example we did for Sonia. So I equals PRT, an easy formula to memorize. So her interest is equal to, what was her principal? It was 1,000 times, oops, there's an extra zero there. 1,000 times her rate. Her rate was 5%, but remember we have to write it as a decimal. And how much time was her money in the bank for? It was in the bond for, it was for 10 years. And you multiply all that together and you get 500. So that's her capital I, that's her total interest. That's her simple interest. It's not this interest rate. That's not what that is. So her interest she made was $500. The other formula we have is a final amount. A equals P, that's the principal, plus this part, right? It's the principal plus the interest. It's P plus I. That's what your final amount is. And since I is equal to this formula, we just substitute in here. Or you could factor out the P and write it like this. It doesn't matter how you do it. Let's use the more complicated version and practice with Sonia's example. So her final amount, A, is equal to, her principal was 1,000. 1 plus her rate was, I know you already know the answer to this, but I'm just going to show you how to do it the long way so that you can do it with homework questions. Her rate was 0.05 and her time times 10 years. Order of operations, make sure you do that multiplication first. So we get 1,000 times, that's a 1.5. When we do the brackets, that leaves us with 1,500. So that's her final amount that we got from the chart as well. Her final amount was 1,500. Here's our only example that we're going to do. 8 years and 3 months ago, Diane borrowed money to pay for university tuition. Stop. You understand that part first, right? She borrowed money to pay for university tuition, but that was 8 years and 3 months ago she borrowed that. So she's probably all done school by now. And she borrowed that money at a simple interest rate of 7.5%. Stop. There's a period. You understand what that is saying. Really important with word problems, you just do one, you comprehend one piece at a time. So when she signed up for this loan, this was the interest rate she was given. So she paid it all off for $7,500. So all that money she borrowed a long time ago, she's paid it all off for this much. So how much did she borrow in the first place if this is what it cost her 8 years and 3 months later? For each question, always write down what you know, determine what you're trying to solve, and then sub into a formula. So write down what you know. So we know, first of all, from the first piece, we're going to talk about 8 years and 3 months ago. Now, those are two different terms, years and months. That's time. We're talking about time, so I'm going to use a T for time. The time we're talking about is 8 years and 3 months. So I want to convert that to years. So 8 years and 3 months, that's 3 out of 12. So that would be all in years now. So that is 8 years, 3 over 12 is a quarter, or 8.25. There's our time. What else do we know from the question? We know that her simple interest rate was 7.5%. So her rate, and that's per year, okay? So her rate is 7.5%, but if you remember from earlier, we can't write that, it has to be written as a decimal. We're not going to use the percent sign, of course. 7.5% is the same as 0.075. What else do we know? We know that she paid it all off for $7,500. So what is that? She paid it all off. That's the final amount. It is not the principal. The principal is what we're looking for. So the final amount was $7,500. What we're looking for, How much did she originally borrow? That's our principal. That's our unknown here. That's what we don't know. Well, let's write out a formula. You've got a couple of formulas to choose from, but when you look at all of the terms that we were able to identify here, we've got a T and an R and an A and a P. You want to use one of the formulas that incorporates all of these. So we will use the one that we did in the example that had, we'll use the factored version. We don't have to, but we'll use the factored one here. The amount equals P times 1 plus R times T. When you draw a T, try to always put a little curve on it so that it doesn't look like a plus sign. Now we sub in. Remember, our amount was 7,500, and that's equal to, P is our unknown, 1 plus the rate was 0.075 times the time, and the time is 8.25. So, getting out your calculator here, let's start with, we'll leave the 7,500 over here. What do we get in this bracket? So using your calculator, and we'll write down several decimal places just so we don't round just yet. You should have a finite number of decimal places showing, so we're going to write them all down. 1.61875. So if you don't have to round, please don't. And if you're working in finance, if you're going to go off to university and do a degree in finance or commerce or business, and you start rounding all the time, well, and you get a job at a bank, they just might fire you, because to them, pennies and fractions of pennies really add up. So we don't round. If at all possible, we work with exact numbers. So we isolate P here, and we divide both sides. We get 4,633.20. That's P. So what does that mean? What is that? So look at your question again. What did we just find? We answered how much did she originally borrow. So that's what we're going to write a therefore sentence here. Word problems require word answers. So Diane originally borrowed $4,633.20, which is not much. You guys going off to possibly university, that's not even going to pay for, one semester of tuition. But she borrowed that much money, and many years later she owed $7,500. That's one example. You don't have to use the formula that way. If you go back, you'll see the other ways you can use the same formula. But I encourage you to try the different methods so that you are comfortable using any of them, and it gives you a better grasp or understanding of simple interest.